Hello, I'm Ravi, and today I'm going to explain about my project, Multi-Control Gesture-Based Mobile Robotic Arm. Basic objective of our project is to build a robotic arm that has 6 degrees of freedom, which can be controlled by our hand gestures. And finally, that robotic arm is mounted onto an Arduino rover for mobility purposes. And to achieve the set objectives, first we started working with an autopilot software. It is an open source autopilot software that is used to build unarmed ground vehicles that can perform autonomous missions. And to perform these autonomous missions, we used a microcontroller known as Pixoc. To install the rover firmware onto Pixoc, we download Mission Planner onto our ground control station and install the rover firmware into it. After the firmware is installed, we do two mandatory calibrations, that is axle calibration and compass calibration. After the calibrations are done, the Pixoc is ready to be armed. Now I'm going to explain the steps I took in order to build a rover. First, I worked with three different motor drivers to see which was best suitable for our project. First, I used a L2910 motor driver, which gave PWM signals but was not the one which was required by Pixoc. So I had to use a different motor driver. This time I used a BT7960 motor driver, which was working fine but was not satisfying needs of our project. So finally, I used a Sabertooth motor driver, um, which was perfect for our project. So I used two of those motor drivers to construct an Omniwire rover. Now this is the Omniwire rover which I built using those two Sabertooths. But due to some unexpected circumstances, one motor driver stopped working. So we had to build a rover from scratch again. This time we decided to build a rocker boogie mechanism which would be mounted onto a rectangular frame which we built earlier. This rocker boogie mechanism will not only support the huge rectangular frame, but will also enable the rover to move on uneven surfaces quite easily, as well as clear small and medium obstacles. And we are steering the vehicle using skid steering method because we have only one saber tooth. Now, this is how a rocker boogie mechanism will be helpful in clearing small and medium obstacles. So, since we were building the rover from scratch again, we decided to work with ROS simultaneously. ROS stands for Robot Operating System. It is an open source framework which can be used by developers to control their robots. It has advanced packages that can be used to write efficient algorithms to control those robots. ROS can be written in multiple languages like C++, Python, etc. So it unlocks more possibilities for a developer to code in his preferred language. Now, currently we are working with the ROS package known as MavROS that converts the ROS signals into Mavlin signals, which are then sent to a Pixoc that controls the rover. Now, these are the things that are to be done moving forward. First, we need to mount the rocker boogie mechanism onto the rover. Next, a 6 degree of freedom robotic arm is constructed, and then that constructed robotic arm is controlled by hand gestures. Um, to control the robotic arm with hand gestures, we have three potential sensors, which we are looking into right now. Thank you.